Hello guys, welcome once more to another video on our YouTube channel. So in today's video we are going to be looking at the entrance examination into the National Advanced School of Public Works Yaoundé, the engineering cycle, that is Meng. So we are going is logarithm to the base 2 of 2 squared, which is 2. So it's an he now came in 2021 with the correct answer. So be very vigilant whenever you're solving questions and there is no correct answer. Always strive to get the correct answer, not necessarily getting a letter, just get the correct answer. So if there is no answer, actually know that okay, there is no answer, that this is the correct answer. Okay, so we are going to first of all indicate a cube, and then we try to section the cube using those planes as we're being told in the question. So practically, when I was teaching last year, I actually did it practically in class. So we bought a Maggi cube. Okay, we bought a Maggi cube, and then now we used a razor blade, and then we sectioned it, and when we counted the number of parallelepipeds that were involved, and we had the correct answer. So this is what we are going to do. Let's begin with the first statement. We kept S with two planes parallel to two opposite faces. So we are going to consider the face, this face here, meaning the left and the right face. Okay, just if possible, right, just hold a Maggi cube and follow up, or a box of chalk, or any box that has a cube-like structure. So we are going to use the face that is, we are going to consider the two faces, the two parallel faces. Our first consideration is the two parallel faces that are to the left and to the right. Okay, so we have this face here and the other face that is to the left. So if a plane is parallel to these two faces, then it must be in the same orientation, in the same direction as those two faces. So I'm going to use these two planes. Okay, so here is the first plane and here is the second plane. All right, now the next statement is saying that we now take three planes and we get the cube with three planes parallel to two other opposite faces. So we are now going to take the face at the top and the face at the bottom. Remember, there are 6 faces, so we have already used 2 already. We are left with 4, and we are using the faces in pairs. So we are now going to take the face at the top here and the face at the bottom. All right, so the face at the top and the face at the bottom are horizontal faces. Therefore means that the planes are supposed to be horizontal. So we kept using these red planes, 3 of them. So we have, so those are the 3 horizontal planes. Okay, and lastly, we now have to get S with 4 planes parallel to the remaining faces. So the remaining faces are now the front face and the back face. The front face and the back face are vertical faces. Okay, they are vertical faces. All right, so we are going to use vertical planes. So there are 4 planes that we are going to use. So we have the first plane, the second, the third, and the fourth. Now we have to count and know the number of parallelepipeds that exist. What is first of all a parallelepiped? It's simply a figure that looks like this. So it is kind of a parallelogram, but in 3 dimensions. All right, so it therefore means that this is a parallelepiped, even this is a parallelepiped, this is a parallelepiped, this is a parallelepiped. All these figures here that look like parallelograms, okay, they are in 3D, they are parallelepipeds. So if we want to count the total number, all right, we are going to just use the formula. We count here you have 1, 2, 3, 4, 5. We count vertically, since we're using vertical planes here, we have 1, 2, 3, 4, and then we now count horizontally. We have 1, 2, 3. So we multiply all of them, and then we get how many? 60 parallelepipeds. So to be more practical, you can take a Maggi cube, right, and then you try to section it. You're going to have some small pieces. If you respect all of these sectionings, you're going to have small pieces. When you count them, you're going to have 60 in total. So B is the correct answer. Okay, question 9 is a little bit long. It reads, the polynomial x to the power 5 plus ax plus 1, option A, has never real zeros. Option B, has at least 1 real zero for each a in the set of real numbers. Option C, we cannot tell if it has real zeros because the degree is too high. And option D, none of the above. Okay, so there are 2 methods that are actually used when solving these questions. Okay, and I'm going to just use one method to make the video a little bit shorter, because I never wanted to make the video be longer. So I'm going to use one method, and that method is very useful in other questions, and it's a little bit shorter. All right, so what we are going to be doing is that we are first of all going to let f of x to be the polynomial given x to the power 5 plus ax plus 1, and we specify that a is a real number. Now we are going to use what we call the Descartes rule of signs. Now this Descartes rule of signs says that what? It says that the number of positive real solutions to an or to a polynomial is equal to the number of sign changes in the polynomial from one variable, from one term to another. This is what I'm saying. F of x is equal to x to the power 5 plus ax plus 1. So we are going to consider separate cases of a. Since a is a real number, it's going to be it's going to be preferable that we take 3 cases. We first of all make a to be 0, we take a to be greater than 0 and a to be less than 0. We are choosing 0 because 0 is neutral. Okay, so we take a to be 0, our f of x becomes x to the power 5 plus 1. Automatically we can deduce that there is no sign change, because you see in most form we are just taking the sign changes. The sign in front of x to the power 5 is a positive sign. Now when you go to the next step, it's still a positive sign, so there is no sign change. And since there is no sign change in f of x itself, then there is no positive real solution. Now let us now look for the negative real solutions. How many of them exist? So the number of negative real solutions are the number of sign changes in f of negative x. Follow keenly. So we are going to find f of negative x, and then you clearly see that how many sign changes are here. There is one sign change from negative to positive. So it therefore means that there is one negative real solution, because there is one sign change in f of negative x. So in conclusion, there is no positive real solution and there is one negative real solution. When we add them together, we have in total one real solution, and that one real solution is negative. So you see that for a equal to 0, there is only one real solution, and it is negative. And clearly we can know that that negative solution is negative 1, because f of negative 1 is 0. Okay, and clearly it is negative. So we have one real solution, which is indeed negative, because of the conclusion from the Descartes rule of signs. Now let's take the second condition, the second scenario, where we now take all positive values of a. The first case we took a to be 0. Now I cannot take a to be 1 or a to be 2. I'm just going to take, I'm going to generalize it. So I take now all positive values of a. My f of x still becomes x to the power 5 plus ax plus 1, and I specify that in that case a is greater than 0. Okay, so let us find the number of positive real solutions. Now we can identify that there is no sign change, right? So there is no positive real solution. No sign change because it moves from here positive to positive. If this a was negative, then everything here is going to be negative. But since a is positive and there is a positive sign here, then the resulting sign is positive. So we have positive to positive to positive, no sign change. In conclusion, no positive real solution. Now we go ahead to get f of negative x. That is replacing x with negative x, taking it to the power 5, and then replacing x here with negative x as well. How many sign changes are here? There is only one sign change. Negative to negative is no sign change, but negative to positive is one sign change. So since there is one sign change, then what's the conclusion? There is one negative real solution, because this one sign change is for f of negative x. So what can we conclude? How many real solutions are there? We have one real solution, which is still negative. All right, so for all positive values of a, there is only one real solution, and that real solution is negative. So for a equal to 0, we have one real solution, which is negative. For a greater than 0, we also have one real solution, which is also negative. Now let us take the last case when a is less than 0. So when a is less than 0, we have f of x to be x to the power 5 plus ax plus 1, and we specify that a is less than 0. But if I actually explain the sign changes here, you might be lost. Okay, so I'm going to specify that, okay, since a is less than 0, it means it is negative. Therefore, it should be what? Maybe I can replace it with negative b, where the b there is a positive number. Alright, negative times positive is negative. So it means that my f of x will be x to the power 5 minus bx plus 1. The b here is positive because there is a negative sign attached to it, which is actually a. Alright, now let us now look for our number of positive real solutions and negative real solutions. So how many sign changes are here in f of x? There are two sign changes. From positive to negative is one sign change. From negative to positive is another sign change. So it means that there are two positive real solutions because there are two sign changes in f of x. Now let us now look for f of negative x. We get this. Now how many sign changes are here? We have negative to positive is one sign change. Positive to positive is no sign change. So there is one sign change here, therefore one negative real solution. So when we add the two positive and the one negative, we have what? 3 real solutions. 2 positive and 1 negative. So in conclusion, we can now conclude that what? When a is equal to 0, there was one real solution. When a was greater than 0, there was one real solution. Therefore, when a is greater or equal to 0, there is one real solution after combining the two situations here. And then now when a is less than 0, how many solutions do we have? We have 3 real solutions. So what's our conclusion? We are concluding now that it has at least one real solution for each value of a. You see that at least one means 1 and above. For it to be 1, your a must be either greater than 0 or equal to 0. Now for it to be greater than 1, your a has to be less than 0, since we have 3 in that case. So option B is correct. Now the other method which I usually do is actually plotting the graph and seeing how many times the graph gets the x-axis. But it might be a little bit longer and complicated for some of us. But if you master this method very well, since you are not actually finding the numerical values of those solutions and you are finding just a number of solutions, then the Descartes rule of signs will be better. So the answer is B. Okay, question 10, we are left with 10 more questions. Question 10 reads, the inequality cos x is greater than root 2 divided by 2 with negative pi less than or equal to x less than or equal to pi has for solutions option A, 0 is less than x less than pi ln 4, option B, negative pi ln 4 is less than x less than pi ln 4, option C, pi ln 4 is less than x less than pi, and option D, none of the above. Okay, so to always solve inequalities, we start by finding the critical values if possible. So here we have a trigonometric inequality. So we need to first of all find the critical values. And the critical values are the points of intersection of the cosine function and the function root 2 on 2. So basic trigonometry, we need to find the principal value and we add it to 2k pi, since we need a general solution before deducing the specific solutions in the interval given. So cos inverse of root 2 on 2 is pi ln 4. We don't use calculators in the concours, so you have to look for shortcuts and you have to memorize how to get the cos inverse, the cosine, the sine of angles. Okay, so our general solution is pi ln 4 plus or minus 2k pi. That is the general solution. Now we are solving an inequality, and I'm going to advise you, whenever you are involved with trigonometric inequalities, go by the graph. So we are going to have a graphical analysis where we draw the graph of cos x in the interval negative pi to pi. We now draw the line y equal to root 2 on 2. Okay, so those are two graphs. We have cos x and we have root 2 divided by 2. Now the 2 points of intersection, remember that we are in the interval negative pi to pi, so those two graphs intersect at 2 points. Those are our critical values. Okay, so we can call the first point x1 and we call the second point, we can call the first one x0 and the second one x1. Okay, now what do we need? The inequality we are solving is cos x greater than root 2 divided by 2. So if you look clearly you're going to see that from x0 right till x1, okay, the cosine function is above the line. That's the interpretation of the inequality. The cosine function is supposed to be above the line. It therefore means that for all values of x that are in this shaded portion here, the cosine function is always above that line. Alright, so what is x1? Our x1 is the principal value, which is this value here, since it is in the first quadrant, 0 to pi on 2. So it is what? Pi divided by 4 when k is 0. Now what is x0? The cosine function is symmetrical about the y-axis, meaning that the x0 here is just negative x1. Okay, so it's kind of a reflection about this axis. So since this is pi on 4, automatically this is what? Negative pi on 4. So the solution set according to our representation here, our x is going to be between x0 and x1. And x0 is negative pi on 4 and x1 is pi on 4. It therefore means that option B is correct. Negative pi on 4 is less than x less than pi on 4. Then cos x will be always greater than root 2 divided by 2. Okay, question 11. The lines of equations y equal to 1 and x equal to negative 1, A, are parallel, B, are perpendicular, C, intersect at 0, 0, and D, none of the above. So we draw our xy plane, we label the axis, we draw the line y equal to 1, it's a horizontal line. We draw the line x equal to negative 1, it's a vertical line. You clearly see that these two lines are what? Orthogonal or perpendicular, clearly. So option B is correct. Question 12. The solutions of the inequality, the absolute value of x is less than or equal to x plus 1 are A, x greater or equal to 0, B, x less than or equal to 1, C, x less than or equal to negative 1 and x greater or equal to 0, D, x greater or equal to negative half. Alright, so first of all, we define what the absolute value of x plus of x means. Absolute value of x is equal to x provided x is greater or equal to 0, and it is negative x provided x is less than 0. So we are going to define cases here. The first case we are going to replace the absolute value of x here just with x, with bearing in mind that the x is supposed to be greater or equal to 0 according to the definition here. So we go back to our inequality and we replace the absolute value of x with x. We subtract x on both sides and we get 0 is less than or equal to 1. This is something that is always true. It therefore means that the solution here is simply the condition, which is x greater or equal to 0. So for all x greater or equal to 0, this is always true. So that is the solution. So we can call that our first solution. Now, the second case, we now replace the absolute value of x with negative x, bearing in mind that in that situation, our x is supposed to be negative, meaning less than 0. So if we replace the absolute value of x with negative x, we can solve the inequality. We subtract x on both sides and then we divide both sides by negative 2. The inequality sign reverses to greater or equal to. So the solution is x greater or equal to negative half. Alright, and now there is something. For us to arrive at x greater or equal to negative half, the condition was that your x must be less than 0. It therefore means that the solution is going to be x between negative half and 0, because you are less than 0 and you are greater than negative half. So the solution of this inequality is a union of the solutions of the two cases. So solution 1 union solution 2. We can go to the number line and indicate the two solutions. We have negative half, we have 0. For solution 1, we have to bold enclose our circle and we take everything greater than 0. We can call that solution 1. For solution 2, we have to include negative half, we exclude 0, and then we take everything between the two of them. But the union of these two intervals, or of these two solutions, is the both intervals, meaning this interval and this interval. And option D is going to be correct, x greater or equal to negative half, because you are taking everything beginning from negative half to 0 and then you continue from 0 All right, so you're taking everything. So the equivalence of the union is simply x greater or equal to negative half. So option D is correct. All right, question 13. The solutions of the inequality logarithm to the base 2 of x less than or equal to 1 are: option A, 0 is less than x less than 1. Option B, 0 is less than x less than log 2. Option C, x is greater or equal to 2. And option D, none of the above. So the first thing to do is that we have to find a domain of definition of this inequality, because the function involved here is not always defined in a set of real numbers. There are some restrictions to it. So for the logarithmic function to be defined, the argument, which is x, must be positive. So that's the domain of definition of this inequality. Now, since the base of this inequality is greater than 1, we follow the convention. Okay, so we are going to have our x to be less than or equal to 2 raised to the power 1, meaning that x is less than or equal to 2. Listen to this. If the base of the inequality was less than 1, first we have to convert it to a base greater than 1 before we apply the convention, meaning taking x and putting the less than automatically. But when it is greater than 1, we just apply the convention already. All right, so from here we have that the solution is x less than or equal to 2. But now you can be less than 2, okay, but you are not in the domain, because negative numbers are less than 2. But when we fit a negative number here, the inequality will not be defined. So that was the essence of getting the domain of definition of the inequality. So we now need to intersect the solution with the domain of definition. So we always intersect with conditions. So the condition for this inequality to be defined is that x must be positive. So we are now doing what? We are now intersecting x less than 2 with x greater than 0. Is going to give us x between 0 and 2. Okay, if you go to the number line and intersect, you are greater than 0 and you are less than 2, and you can be equal to 2 as well. So it means that you are between 0 and 2. So option D is correct, none of the above. All right, question 14. In the Cartesian plane xy, the region xy, a couple belonging in arrow square. This just means that x is in arrow and y is in arrow. That's why if you write it as a couple, it's xy in arrow square. Okay, now the absolute value of x plus y is equal to 1. What is a representation? All right, so first we give the implication of absolute value of x plus y equal to 1. What does it mean? It simply means that x plus 1 will be plus or minus 1. Okay, because it is only plus or minus 1. Now when you take the absolute value, it's going to give you 1. Okay, so x plus 1 should be either negative 1 or it should be 1. Now if we look for y as a function of x, we are going to have two lines. The first line is negative x minus 1 and the next line is negative x plus 1. The two lines are parallel to each other. Okay, and they have different intercepts. So we now go to the xy plane, we label our axis, we now draw the graphs. So these two intercepts are for the first line. When x is 0, y is negative 1, here is the intercept. When y is 0, x is negative 1, here is the intercept. We link the two intercepts and we extend. So we have the first line. Now for the second line, when x is 0, y is 1, that is the point. When y is 0, x is 1, that is a point. We link the two and extend. So which option is correct? Option A. Alright, question 15. We have A, cos inverse of negative pylon 3 is equal to pylon 6 is equal to negative pylon 6 is equal to 5 pylon 6, or none of the above. So first of all, the sine function is an odd function. So we first of all deal with the interior before taking the cos inverse. So since the sine function is an odd function, it therefore means that the sine of negative pylon 3 is the same as negative the sine of pylon 3. Pylon 3 in degrees is 60 degrees and the sine of 60 degrees is root 3 on 2. So the sine of negative pylon 3 is negative the sine of pylon 3, as we have seen, which is now negative root 3 divided by 2. Now we need to find the cos inverse of negative root 3 divided by 2. And we should recall that whenever we add the cos inverse of an angle to the cos inverse of negative of that angle, we always get pi. Okay, we can prove it, alright, but there is no time to do that. So it therefore means that to find the cos inverse of negative root 3 on 2, I will just take pi minus the cos inverse of root 3 on 2, because we can find the cos inverse of root 3 on 2. The cos inverse of root 3 on 2 is an angle that when you take the cosine of that angle, you get root 3 on 2. And that angle is simply 30 degrees, which is pi ln 6. So the cos inverse of sine of negative pi ln 3 is pi minus pi ln 6, which is 5 pi ln 6. So option C is correct. Question 16. For each couple A and B being real numbers, with both of them being positive and A is less than B, we always have option A, arctan B is less than arctan A. Option B, cos A is greater than cos B. Option C, tan A is less than tan B. And option D, none of the above. So I try to draw the graphs of these various functions: tan inverse, cosine, and tangent. So here's a graph of cos x, here's a graph of arctan x in the positive interval, and here is a graph of tan x in the positive interval. Now let us analyze. Let's begin with cos x. Okay, so if A is less than B, does it mean that cos A is greater than cos B? Let us see if that is true. So I pick A to be here and I pick B to be there. Now what is cos A? That is cos A there. And what is cos B? Here is cos B. You see, cos A is a positive value and cos B is a negative value. It therefore means that cos A will be greater than cos B. But what if now I take my A to be 90 degrees and my B to be 270 degrees? So we have A to be 90 degrees and B to be 270. Cos A will give you 0 and cos B will give you 0. You see, they are equal. So it therefore means option B is wrong, because if A is 90 and B is 270, both of them are positive and A is less than B. But the cosine of A is 0 and the cosine of B is 0, and you come and place here, you are going to get 0 greater than 0. Impossible. So option B is out of the way. Let's now go to arctan, option A. So this is the tan inverse function in a positive interval. It is increasing in that interval. So if it is increasing in that interval, if I take A to be this and B to be this, now if you look for cos A and cos B, we are going to get cos A and cos B to be those two red dots. Our cos A is below cos B, therefore, arctan A and arctan B. Our arctan A is below arctan B because A is less than B, and the function arctan is increasing in the positive interval. Alright, so clearly we see that arctan B is greater than arctan A. So option A is gone. Option A, which is saying that arctan B is less than arctan A, is incorrect. Now let us go to the last graph, which is for tan x. Alright, so I consider A to be here and B to be here. Now if you look for cos A and cos B, we are going to get those two dots. You see, cos A is what? Positive. Cos B is what? Negative. So cos A is greater than cos B. These are just examples I'm taking. Alright, you could also take examples that will work, because these functions have different sense of variations depending on the interval. There are intervals where they are increasing, intervals where they are decreasing, and the results might be reversed. So I'm just taking random examples. Alright, so you see, in this last case, your cos A is a positive value and tan A is a positive value and tan B is a negative value. So you see that tan A will be greater than tan B. So option C is saying that tan A is less than tan B, which is wrong. So what can we conclude? Option D is correct. None of the above. Okay, question 17. Let T be a triangle whose edges are 8, 15, and 17 centimeters. Then, option A, the triangle T is similar to a triangle having sides 3, 4, and 5. Option B, the triangle T is not a right angle triangle. Option C, the triangle T is similar to a triangle having sides 7, 24, and 25. And option D, none of the above. So let's begin with option B. Or whenever you're given 3 sides, okay, that, and they say the 3 sides form a triangle, the first basic triangle you have to test for is a right angle triangle. So you have to test if the square of the longest side is equal to the sum of the squares of the other 2 sides. In this situation, it is, because 8, 15 and 17 are Pythagorean triplets. So it means that the triangle T1 is a right angle triangle. We can sketch it. Now let us say, okay, that is the triangle T. Now let us call the triangle with sides 7, 24 and 25, let us call it T1, and then the triangle with sides 3, 4, 5, let us call it T2. We now verify if they are also right angle triangles. So for this guy here, 7, 24 and 25 are also Pythagorean triplets, because 25 squared is 24 squared plus 7 squared. So our T1 is a right angle triangle. Here is a sketch. The basic, or the first basic Pythagorean triplets are 3, 4, 5. Alright, so 5 squared is 4 squared plus 3 squared. So T2 is a right angle triangle, and that is a sketch. So therefore means that option B is wrong, which is saying that T is not a right angle triangle, since we already identified that it's actually a right angle triangle. Okay, now let us now look at option A and option C. It's talking about similar triangles. So I'm going to give you 2 triangles, and I'm going to give you the condition for any 2 triangles to be similar, or any figure to be similar, but in this case we deal with triangles. So I'm going to consider the triangle A here, and I'm going to consider the triangle B here. Now we say that these 2 triangles are similar if and only if the first thing is that the ratio between their corresponding side lengths are supposed to be equal. So if I take A divided by A1, those are corresponding side lengths, the height. It should be the same as B divided by B1, and it should be the same as C divided by C1. The second condition is that the angles in those triangles must be congruent, meaning they must be either equal or multiples of each other. But to actually solve this question, we are going to dwell on the first case, meaning we do the ratio between the corresponding sides and we verify if they are constant, or if they are the same. So let us begin with the first one, that is option A, which is saying triangle T, and this one is T2, right? Let us do the ratio between corresponding sides. 17 hypotenuse divided by 5. 17 divided by 5 is it equal to 15 divided by 4, and is it equal to 8 divided by 3? So you see they are not equal, alright, because 17 divided by 5 is 3.4, 15 divided by 4 is 3.75, and 8 divided by 3 is 2.66. So they are unequal. Therefore option A is wrong, which is saying that the triangle T is similar to T2. Now let us look at triangle T and T1. We do the ratio between the corresponding side lengths. 17 divided by 25. 17 divided by 25 is 0.68. 15 divided by 24 is 0.625. They are already unequal, so we can even end there. But if we take 8 divided by 7, it's going to give us 1.14. So you see that the responses are not equal. Therefore triangle T is not similar to triangle T2. So in conclusion, option D is correct. Alright, question 18. Let x be a real number, then the absolute value of e to the negative x minus 2e to the negative 2x is equal to 2e to the negative 2x minus e to the negative x for x less than 0, for x greater than log 2, for x less than log 2, and for x greater than 0. Now note, when you see log, okay, sometimes it means to the base 10 and sometimes it means to the base e, it means lean. So in any of the cases, you always verify to see if it means log, to the base 10 or it means log to the base e, that is lean. Alright, so we are going to define what the absolute value of f of x is all what the absolute value of f of x means. The absolute value of f of x is equal to f of x if f of x is positive, and it is negative f of x if f of x is negative. You should note that the absolute value is a positive function. Okay, so when they say it is negative f of x, it doesn't mean that it is negative. Why? Because the f of x itself is negative. So when you multiply the negative and the function itself, which is negative, it yields you a positive function. So be very vigilant. Don't say the absolute value or the magnitude is negative. It's not negative. It's negative of the function, provided the function is negative. So you multiply the two and you get a positive result. You see, and it is positive of the function if the function is positive. So in all cases, it is positive. So we are going to define what this absolute value is. So the absolute value of e to the negative x minus 2e to the negative 2x will be positive. In fact, it's going to be itself if it is positive, and it's going to be negative of itself. If you multiply this interior here by negative, you're going to get a switch of position of the terms, okay, provided itself is negative. Now if you look at all the responses, it's just dwelling on the second case. So it means that the absolute value will be the second case if e to the negative x minus 2e to the negative 2x is negative. So if you multiply all through by e to the power 2x, we are going to arrive at e to the x minus 2 to be less than 0. Because you multiply this by e to the 2x, it will give you e to the x. Multiply this by e to the 2x, it will give you negative 2. Multiply 0 by e to the 2x, it will give you 0. And since e to the 2x is positive, then the inequality sign remains less than. From here, we have e to the x less than 2. You take ln on both sides, you're going to get x less than ln 2. So in this case, they consider the ln to be log. Okay, so x is less than log 2. So you now see that what? That the absolute value will be negative of itself. The absolute value of the function will be negative of the function provided your x is less than log 2. So if you check closely, option C will be the right option. Okay, question 19. Inequalities once again. The solutions of the inequality: the square root of x minus 3 of x minus 1 less than 3 minus x is... Okay, so option A says that 1 is less than or equal to x less than or equal to 3. Option B says that x is less than 2 union x is greater than 5. Option C says 1 is less than or equal to x less than 2. And option D says x is equal to 1. Okay, so the first thing to do is that we find a domain of definition of this inequality. We are doing that because not all the functions here have domains as a set of real numbers. In certain situations, we don't find the domains because the functions involved are always defined for all values of x. But this is not the case, okay, because the square root function has to be restricted. So we find a domain of definition, and the domain will be such that the square root, the domain of definition of the inequality is the domain of definition of the square root function, okay, because 3 minus x is a line, so it is always defined. Now for the square root function to be defined, the interior has to be greater than 0 or equal to 0. Doing that and solving, you get that the inequality is defined for all x greater or equal to 1. We can indicate that solution, that inequality on a number line. Now we have to square both sides. That's the only thing we have to do, and we don't just square both sides like that in inequalities. Be very vigilant. For us to square both sides, those sides must be positive. We now come and look at these two sides. The square root function is a positive function, so the square root of 9 is 3, the square root of 4 is 2, and not plus or minus 2. So note, the square root function is a positive function. So to square the both sides of this inequality, all of them have to be positive. Since this man is already positive, then the condition for squaring both sides will dwell just on the sign of 3 minus x. So for us to square both sides, 3 minus x has to be positive, meaning that x has to be less than 3. When you square both sides, in fact, let's just indicate x less than 3. So we open our circle at 3 and we take everything going downwards. Alright, when you square both sides and simplify, you're going to arrive at x minus 2 times x minus 5 greater than 0. This is a quadratic inequality which has already been factorized, so we can just get the critical values by equating the factors to 0. We equate x minus 2 to 0, we get x equal to 2. We equate x minus 5 to 0, we get x equal to 5. If we go to our number line and then we indicate x equal to 2 and x equal to 5, so that is 5 and then that is 2. We now do our sign test. We take values above 5, we replace in the function here, then we multiply, we simplify, and we know the sign. So let's take 6. 6 minus 2 is 4. 6 minus 5 is 1. 4 times 1 is 4. It is positive, so the sign there is positive. So there is now alternation of sign. So between 2 and 5 you have a negative sign, and less than 2 you have a positive sign. But what do we need? We need the interval. X is supposed to be in an interval where when we replace x here and replace here and multiply, the result is supposed to be greater than 0, meaning positive. So for all x that are greater than 5 and all x less than 2, it works. So the solution set is x less than 2 union x greater than 5. But for us to arrive at this situation, we use the condition that x must be less than 3. So we intersect x less than 2 union x greater than 5 with x less than 3. You're just going to get x less than 2, okay? Because all your solutions are supposed to be less than 3, and all solutions greater than 5 are not less than 3, so that region is cancelled. But all solutions less than 2 are less than 3, so the solution is x less than 2. But if you are less than 2, you must be in the domain of definition, because 0 is less than 2. But if I replace 0 here, I'll have the square root of -1. The inequality is already not defined in the set of real numbers. You're not getting to complex numbers, right? So you now see that we have that was the reason of indicating the domain. So the solution is x less than 2, as we have seen. But now we need to bring it out to the number line of the domain. So less than 2, we have that. You also have to be greater than 1, meaning that you are supposed to be less than 2 and greater than 1. So it means you should be between 2 and 1, and we can take 1 because the square root of 1 minus 1 is the square root of 0, which exists. So option C is correct. Inequalities is one of the most important, complicated at the same time, where you can easily fail topic in the concours of public works. Look at option B. Somebody who just square both sides without even considering the condition or the domain will automatically pick option B, x less than 2 union x greater than 5, and fail. So you have to be very vigilant. Finally, question 20. In one city, all residents with ages 60 or over have received 2 doses of COVID-19 vaccine. Mr. Giovanni received only 1 dose. So inevitably, sorry guys, I never actually indicated, I never actually added a slide for the solution of this question. I forgot about that. So I just put the answer. So in the next video, so the answer is actually D, okay? So in the next video, I'm going to explain, I'm going to begin with question 20 before entering question 21. So do well to share the video, so I'm going to be motivated to do the next video. All right, see you guys in the next video. Thank you for watching. Share the video with your friends, subscribe to the channel, like the video, comment. Your comments are very important. They go a long way to motivate me and inspire me to be able to produce other content once I feel that people are actually being helped by the videos. So always notify when the video is good. Thank you very much, and see you in the next video.